All right, well, foolish me. I didn't press record last time. So here we are. We're re-recording it. So we are now looking at your senses here, and we have three main questions. What are the different sensory structures, and what are each of them able to detect? Uh, so what are the organs? How do they detect? What do they detect? How is each sense organ able to transmit a nerve impulse? And then what is the relationship between smell and taste? So starting out here, we're looking at taste and smell. So your taste buds detect chemicals. So organ, and what they taste, and these are the different ones. That one you have sweet receptors, sour, salty, bitter receptors. You have umami receptors. There's a couple of other hypothesized ones, but that's not really relevant for the course in this case. Um, so these are the so this is like the organ, and they detect chemicals. Now, these receptors, smell and taste, are connected because, as you can see, they share a passageway here, right? So not only do they share a passageway, but they both also detect chemicals. They're both detecting chemicals and comes in through the nose. So if you've ever seen in characters in the movies and TVs, bottoms up, I guess. They do that. It works. Try it out. I promise you, it works. You're getting less of the you're not getting the same amount of chemical receptors because it's not coming in through your nose. Um, yeah, like it works. I promise you. But anyways, yeah, they share chemicals. They share a passageway, and it's done through your olfactory bulb, the receptors here. Now, there's for light, it goes, right, right. What is light? What is sight detecting? It's detecting light. So, what are you detecting? Light. How are you detecting it? You are detecting this through your eyes, right? That's the organ. What does it use to detect it with? A couple things. Right? So, light goes into your cornea, which then goes into your pupil, which then goes into your lens. And then from your lens, it inverts and gets sent to your retina, where then your optic nerves use the cones and the rods to see it. Oh, my video's still on. Whoops. So that's how that works. Now, one thing that's important to note about this is that, sorry, not important, but interesting. Rods and cones, one detects light, one detects color. Not all animals have those or have the same amount of them. Dogs don't have any of the light, or sorry, of the color sensing ones. So they see in black and white. Birds have way more of the color sensing ones. So they see colors we can't even comprehend. Now, how does light work? Well, I've prepared a little bit of a document here to kind of help you out here. Look at the bottom. Curious pirates invade large rocky river bridges. Say it with me. Curious pirates invade large rocky river bridges. Curious pirates invade large rocky river bridges. So this is an acronym. It's an easier way to remember this. Just how when you were a kid, you probably learned something like never eat soggy waffles for northeast, south, and west. It's the same concept here, just a little bit more difficult. So light enters your cornea, which is then focused by the pupil. Your iris controls the pupil, controls the size of the pupil. That gets sent to your lens, which then sends the image to the retina, which then sends it to your receptor cells, your rods, your cones, and finally into your brain. So, how does hearing work? So, hearing and balance are also kind of connected a little bit, not in the same way as the other ones are. So, what is hearing? Hearing is sound waves. What's a sound wave? It's a vibration in the air. That's what a sound wave is. So these enter the ear canal and go into the tympanum. What the heck is that? That's your eardrum. Eardrum. Okay, that's what that is. So it goes for the rest of the class. I'm referring to it as eardrum. Okay, you can refer to it the tympanum if you want. It's eardrum, right? Just let's speak in some English language here. So this enters your ear canal, your auditory canal, and causes your eardrum to vibrate. These vibrations then carry up through a couple of bones, the malleus, incus, and stapes, which then start to cause fluid in the cochlea to move. The vibrations move the water in your cochlea, which then gets interpreted by the brain. Right? Ed's very small octopus caught here in bubbles. Ed's very small octopus caught here in bubbles. Write this acronym down, helps you remember it. So your waves enter your ear. Your eardrums vibrate. It then goes into a couple of bones. The stapes is the important one here because it's the last one. So the stapes then vibrates and causes your oval window to move back and forth. This oval window causes the cochlea fluid to move, which then gets actually, you can let hair cells there. That's fine. Technically not correct, but we'll, for simplicity's sake. So it causes the fluid to move, which then gets interpreted but to the brain. Now your ears also control balance here. Now this is done through these semicircular canals, right? So these tell your body about where this body's position is. So how do these work? Have you ever spun around really, really, really quick and now you're dizzy? Oh, whoa, whoa. And you've lost your balance, right? Well, that's because you have messed up what the semicircular canal used to detect. Have you ever gotten a little too drunk and you get the spins, or you fall over much easier? Well, there's a reason for that. It's because you've messed up the interpretation from the information of the semicircular canals. So, how do these work? Well, these are filled with fluid and lined with hair cells. These fluid rubs against the hair cells whenever your head moves, and then this sends the information to your brain. So when you spin around, you lost your sense of balance. That's because you've activated all of the cells. So you can't actually differentiate them. If you're really, really drunk, that's because your body doesn't interpret all the signals correctly, for example. And oh my God, I have the spins. That's why. So touch, last one here. So touch responds to three things: temperature, pressure, and pain. Temperature, pressure, and pain. I can detect both cold and heat in here, two separate ones. I can detect both heavy pressure and light pressure, two separate ones. And then free nerve endings are what can track the pain here. So temperature, pressure, and pain, and they are found in the skin. All right, so I want you to actually at this point try and answer these. So this is the what? This is the organ. I want to know how they detect, and I want to know what they detect. So organ, how, what. I want you to do your best to write this down, guess. You'll learn it better that way. I'm going to go over it in 3 seconds. 3, 2, make sure you pause the video and do it. 1. So your taste buds detect, so remember, the organ, the how are they detecting it? What are they detecting it? What are they detecting? So your taste buds, the organ, use sensory neurons to detect chemicals. Your smell uses those nerve receptors, olfactory nerve receptors, to detect chemicals. Your sight uses rods and cones to detect light. Your hearing uses, this one's a little bit trickier, but like generally speaking, vibrations to detect sound waves, or fluid against hairs. I would count that too. But you do still want to include sound waves or vibrations. I'll count them both as one in this case. Your balance is fluid movement against hairs, and your touch is receptors and nerve endings, which remember do temperature, pressure, and pain. How are smell and taste connected? Well, they both use chemical receptors and they share the same passageway. All right, so make sure that you guys finish this up and then head on to the last one, which is section 4, where we will be talking about drugs.